Python and files. Let's look at how we take information from temporary memory, store it long-term on a hard drive. So temporary memory is in RAM. When you turn off the computer, it's gone. We want to learn how and why and the concepts of saving information on a long-term basis. So temporary memory is also called volatile memory, random access memory. It needs to be there because the CPU can only do, we'll just use an analogy, say it can only do one thing at a time. So it has to have some place to store the information that it needs to process next. So if we pretend that, there we go, this is our CPU, well, it can only do a few things at a time. So we need a place over here in temporary memory so that things can get swapped back and forth because it needs to be very quick access. But if we turn off the power, well, you know what happens when we turn off the power. It all goes away. So we want to have another level. We have our CPU where our work happens. It's transferring stuff from the CPU to memory as our program is working and processing on things. When we want to save something permanently, we have to go a lot further and it takes a lot longer time to store it in the file system. But this is not transient. This is more of a permanent solution. So when we turn off our computer, we can turn it back on, load our program into memory again, and pick up where we left off. We've done that with some of our SQL programs. We've done some pickling. We're going to do a little bit of more work with that this week with files. So let's clear that out. So there is also, besides RAM and the CPU, there's high-speed cache memory. So yeah, there's lots of little storage places, isn't there? So we have our CPU. Oops, my little drawer's not working. Here we have our CPU. Right next to the CPU is very high-speed, and actually some of it's actually on the CPU. This is very high-speed RAM that as the program is calculating things, it's shuffling back and forth very quickly. Well, if the CPU doesn't need something for a certain amount of time, it gets shuffled off into memory. And there's actually 3 stages of it. L1, L2, L3 cache. Then it gets shuffled to memory. If this hasn't been used for a while, then it gets shuffled out of memory, or you could save it to the hard drive. So there's various stages and various ways that we can store our information. So we're looking at secondary storage. That's one term for it. It's non-volatile, it's long-term. Typically our stuff that we're using now is almost always going to be an SSD drive. It might be saved on a network. It's not going to be as fast, but it doesn't need to be because we're storing things for the long term and our programs aren't going to do a lot of disk reading and writing. So we're going to typically load the whole program in memory, do something with it, and then close the whole program. So files are not transient in nature. When we open a file, like I double-click to open up this file from memory, the operating system opened up what's called a file handle. It's it says it returns an unsigned integer, but really you can think of it as a handle on a suitcase. If the suitcase is your file, the file handle is the handle on the suitcase, so the operating system can do something with it. So we open it up. The operating system says, okay, here's this file. We open it up into memory, and then we can process and work on it. And then when we're done, we can save it to the hard drive. We can copy it out of memory to the hard drive, or storage area. We can copy from the storage area into memory. We can copy from memory into the storage area. And this is just another diagram of the same thing. So we're going to look at 3 modes of writing. We can open a file just to read it. We can open a file for writing. Well, that erases the contents if the file exists. I don't know where that guy came from. We can also append to the end of a file. Well, let's look at how we open and close files. We use the open command. Well, that's not very hard. In Python, things are pretty easy. Open opens a file. This first part is the name of the file. This is assuming it's in the same folder. R means we're going to read it. So if the open is successful, we get a file handle named text file. We can now manipulate that file in memory. Remember, we're not doing anything to the hard drive file. That's file operations like deleting and copying and pasting. When we open a file into memory, we can manipulate the file, and then we can save the file back to the hard drive. But we're not actually manipulating the file on the disk. All right, so we read, we can open, we can close, we can read, we can write. We're basically copying information from a long-term storage device into the program. When we're done, we release it or we save it. All right, so there's a couple ways that we can do directories. We're going to mostly do directories that read things that are in the same folder. So we're not going to worry about paths until later on. So here's a sample text file. This is a very simple little program. Give me a second to get the file open. Here we are. Here's our little program. We're going to open a file called example.txt in read-only mode. So we open that file handle. This file handle now has a hold of all the information that was in that file because it's opened and copied. So we're going to read that file handle into a string, so now we can do something with that information. Once we're done, we close the file handle. We close that connection between the operating system and the file, but the string is still in memory, so then we can print it out. And there's my example.txt. When we run it, it all happens pretty quick. Adios. All right, well, that's good. We have better ways of doing things, just like we found out with SQL. We can do things in several steps. We can eliminate some steps and be a little more efficient. We've used the with operator before. The with operator means with this text file, we're going to open it as this file handle. So now we have this file handle. We're going to read the contents into a string. And notice we don't have a close because just like in SQL, when we leave the with operator, it automatically closes when you exit the with statement. So this is a preferred way to handle files in SQL and other things that we're going to do because it handles closing all on its own. So far, so good. Well, let's write to a file. I have Rockstars. I don't know if you know, probably you've heard of Eddie Van Halen. Regardless, we do the same thing we did before. We're going to open this file handle to this file, right? So now we have a hold of the suitcase. We're going to take that suitcase and write the word Eddie Van Halen with a new line in it, so it goes to the next line. We're going to write Eric Clapton. We're going to write Steve Gadd. And then we know that it's written successfully because if it wasn't written successfully, we'd have an exception. So let's go ahead and run that. And it was written successfully. Well, let's find out if it was. Let's see, Rockstars. It was way at the bottom. So there's Eddie Van Halen, the string, put in a new line. Eric Clapton, new line. Steve Gadd, new line. So it did exactly what we thought it was going to do. We wrote to the file handle. When we closed the file handle, that wrote that file to disk. Here we're working with that file in memory. Okay, so when we open it from the hard drive or from the storage device, we're opening it up in memory. This file handle allows us to access it through the operating system. Python's not directly accessing it. It's using the operating system to access it. We write this information to the file in our suitcase, and when we close the with, closing writes the file. All right, so now we should read that guy, shouldn't we? Okay, so we wrote our text file. Let's find out here where we are. There it is. All right, so we're going to read our text file line by line. Now we open the file into memory. We get our suitcase open with our file handle. We read the first line into a string. Remember, Rockstars has this. And remember, the first line also includes that enter character. Text enter character. Remember that /n is a text character. So we read these all in, and if we don't do the right strip, oh, here we go. If we don't strip off that enter character, look what happens. So we open it up, we read them into 3 separate strings, we print them, look what happens to it. Ooh, we have extra lines. So we want to do rstrip, which means strip out on the right-hand side this character. This is the new line character, or the enter key character. When we read it with that, everything comes out just fine. There it is, Eddie, Eric, and Steve. Okay, when you're working with strings, be aware that at the end of a line, there's a new line character, and rstrip, you can strip anything off the end of a string. You can do lstrip, rstrip, you can strip off of each side of a string. We're going to do more work with strings as we go. Well, of course, the next thing is, let's append, right? We're opening it in append mode. That means we're going to add these guys to the file. We're going to write to the file handle, but we're not going to overwrite what's in there. We're going to add it in there. So let's add it in there. There we go. So we should have, as a matter of fact, we do. We just keep adding and adding and adding and adding, kind of like a log file. It's not really a good way to do log files. There's a built-in log file function, but you can add to it. That takes care of text. Let's move on to numbers for the next video.